Welcome to another virtual physics lecture. Today we're going to be discussing work and power. Be sure to take good notes and let's begin. In science, the word work has a very different meaning than what you may be familiar with. The scientific definition of work is to use a force that will cause a displacement in an object's position. However, there is a big requirement that's needed, which is that both force and motion must be in the same direction. Okay, so let's take a look at these scenarios and identify if there is work being done in scientific terms. First one, a weightlifter picks up a set of weights above his head. Well, let's think. There is force being applied and there is displacement of the object's position. And they are both in the same direction, so there must be work done. Okay, the next one, a scientist giving a lecture to his peers. Let's think about it for a bit. First off, is there any force applied? Well, some may argue that there is a force applied by speaking, but despite this type of energy usage, there is no push or pull, which is how we identify a force, and there is no displacement of the object's position. Thus, unfortunately, there would be no work done. Okay, what about this last one? A mouse pushing a piece of cheese with its nose across the floor. Okay, well, there is force applied to the cheese, and there is displacement of the object's position, so there must be work done. Okay, so the two things needed in order for work to be done is the application of a force and the movement of something by that force in the same direction. So let's take a look at these two scenarios. No work is done by pushing against a stationary wall. However, work is done throwing a ball because the ball moves forward while being pushed forward during the throw. Let's take a look at the cheese and mouse example again. The mouse is using a force to move the cheese in a certain distance. However, it is important to note that the force applied to the cheese is in the same direction in which the cheese is moved towards. So now that we know how to identify if work is actually being done, now we need to know how to calculate this work that's being done. And to do so, we need to know this formula. Work equals force times distance. Notice that the units for force are newtons and the units for distance is meters. Therefore, the units for work should be newtons times meters. However, we like to shorten this unit by simply calling it a joule, often represented with a capital J. Let's take a look at this example for calculating work. Okay, in this scenario, they want to know how much work is performed when a 50-kilogram crate is pushed 15 meters with a force of 20 newtons. Let's first start by identifying if work is actually done. First, is there a force applied? And in this case, yes, there is. And second, is there movement because of that force in the same direction? And in this case, yes, there is. Okay, now that we know that work is actually being done, let's now make a list of what we are told. So the mass of the crate is 50 kilograms, the distance of the crate that it's moved is 15 meters, and the force used to move that crate is 20 newtons. And we want to know work. Well, the formula for work is force times distance. Thus, we don't need to know the mass, so we can just cross that out. Now let's plug in the numbers and multiply 20 times 15, which gives us 300 newtons times meters. And remember, I can just shorten that unit by using a capital J to represent joules, and that would be the work done. Let's first start by identifying if work is actually done. First off, there is a force that is being applied by pushing the weight up. And second, there is movement of the weight set in the same direction that the force was applied. Thus, work is done in this scenario. Now let's make a list of what we know. First off, we know that there was a force of 980.4 newtons that was applied in order to raise this weight set up. And there was a distance of 2.04 meters. And we're looking for work. So now all we need to do is plug in the numbers and multiply 980.4 times 2.04, which gives us 2,000 joules. Okay, now that we understand what is work, let's try to take a look at what is power. Power is often used to describe how fast work is being done, which is why we identify power as the rate at which work is done. giving us the formula of power equals work divided by time. Because the units for work are joules and for time they're seconds, the units for power should be joules per second. But we like to shorten it to a unit that we call watts. Okay, let's take a look at this example in which a mechanic used a hydraulic lift to raise a 12,054 Newton car 1.89 meters above the floor of the garage. It took 4.75 seconds to raise the car. What was the power output of the lift? Well, let's start by making a list of what we know, which is the force, 12,054 newtons, the distance, 1.89 meters, and the time, 4.75 seconds. But notice, the equation for power is work divided by time. So in order for us to solve for power, we first need to solve for work. We can do that with the information we know, can't we? Well, yes, we can. We can simply plug in the numbers for force and distance into the equation for work, which would give us 12,054 newtons times 1.89, giving us work of 22,782 joules. Now we can plug in these values for work and time into the power equation, giving us 4,796 watts. Okay, so that's it for this video. Hope you guys took good notes, and I'll see you